Hi, welcome back to class. In this lesson, we are going to be talking about the more advanced questions that come in question 9 on your CSEC math paper. This is a continuation of a lesson previously done that dealt with bearings, and if you have not watched that video yet, you probably should go do it before you continue this one. If you already have a basic idea of bearings and you already know the sine and cosine rules, then we can continue with this lesson and explore as we go through some questions to see how to manipulate and how to deal with those questions that come up on the advanced side of the paper. So before we get into that, we need to talk about some minor things. Yes, you need to remember how to use the cosine rule. You need to remember how to use the sine rule. Those are very important in this part. And these ideas of opposite angles, angles at a point, corresponding angles, alternate angles, and I'm adding here cointerior angles. Now, angles at a point measure 360 degrees, and so this angle will be opposite to this one, and they are equal to each other. Likewise, this is opposite to this, they're equal to each other. When we have parallel lines, and you will have many parallel lines when you're working with bearings, for the very fact that your north lines will be parallel to each other. From that idea comes this thing of alternate angles, especially. Not so much the corresponding ones, but especially the alternate ones. And I'm turning the diagram this way, the same diagram, turning it this way for you to see what I mean. These two lines, I'm going to designate them as north lines, and they will be parallel to each other. So this angle A is equal to this angle B. They're corresponding, but especially here, I'm dealing with the Z angles. So the Z angles, or what we call cointerior angles, if you should measure it this direction, and you see you have a Z, and the Z here represents C and D. Those are alternate and they're equal to each other. Likewise, if you take it to the other direction, this is A, this is A. So you have that one there. Those two angles will be equal to each other, B. So A will be equal to B. Likewise, C is equal to D. And on your bearing diagrams, the lines are going to be looking this way, pretty much vertical. So it's the same idea. You can see a Z, just that it's in a different orientation, or here. And these angles on the inside, we call them cointerior angles, C and B. Now, C plus B here would be equal to 180 degrees. They're supplementary angles, and this is a very important thing to remember, especially as it concerns working with bearings diagrams. So these two angles measure 180 degrees. They are cointerior. They are on the insides of the parallel lines. So here's your north line, here's your north line. This angle C plus this angle B would give you 180 degrees. It's a very useful thing to remember. Can save you a lot when you're working with bearings. Also, the idea of the Z angle comes up a lot, so you need to be familiar with those. So what do you need? You need sine rule, you need cosine rule, and you especially need to remember this idea of the Z angle and the idea of the cointerior angles. All right, so we have 5 questions that we want to look at. The first one will require us to draw it ourselves. So let's this is a CXC question. Let's look at it and see what it says. A boat leaves a dock at a point A and travels for a distance of 15 kilometers to point B on a bearing of 135 degrees. The boat then changes course and travels for a distance of 8 kilometers to a point C on a bearing of 60 degrees. So the first thing we need to do here is that we need to draw our diagram. And the question is asking us to illustrate it to clearly show the north direction, both bearings, and both distances. So we are going to start first by putting in our north line. So let's put in our north line. Every time you're going to start a bearings question, you must draw your north line. So the first one says the ship leaves A and travels to B. So this point here is A. It's going to travel to B, 15 kilometers on a bearing of 135. Remember that here is 90, this is 180 degrees. I'm going to erase them, but just so that you remember. So 135 is going to be between 90 and 180. So it's somewhere here. And this is your angle 135 degrees. And here's your A. Now the ship stops at B. So this is your B. Now the question says that it leaves B and travels to a point C on a bearing of 60 degrees. Because we're going to draw another bearing, we must put in another north line. So we're going to put in another north line here and 60-degree bearing somewhere there. And this distance here now is equal to 8 kilometers. This one was 15 kilometers. And let's write that properly. 15 kilometers. And we are finished. We have both our north lines. We have our 135 degrees, and now we have our 60 degrees. So we are showing what the question asked for, the north directions, the two bearings, one here, and the two distances of 8 and 15. So that part of the question done. Let's look at the calculations. It says we are to calculate the distance AC. Now this would be the point C, because the ship would stop here. So let's label that as C. Now we want to calculate AC, so we want to calculate the length of this line, AC. We can use the cosine rule to calculate the length of that line, because we know this side and we know this side. And we almost know this angle in the middle here. We know that this part of the angle is 60 degrees. We do not know what this part here yet is, but we can find it. Remember the idea of the cointerior angles? Well, this 135-degree angle, will be supplementary to this part of the angle because they are between the parallel lines. So we have 135 plus this angle should give you 180 degrees. So 135 plus that missing part should give you 180 degrees. That should tell you that the missing part of the thing is 45 degrees when you subtract 135 from 180. So right here is 45 degrees. And so we now know our big angle right here to be 105 degrees, because 60 plus 45 gives us 105. And now we can use the cosine rule to calculate the length of AC. Let's do that. So we can write the cosine rule as AC square is equal to 15 square plus 8 square minus 2 times 15 times 8 cosine of 105 degrees. And once you type that in your calculator, you should get 351 point, roughly 351 kilometers. And now we can find AC by taking the square root of this. So we take our square root, and once you find the square root, it should give you roughly 18.7 kilometers. So this distance AC turns out to be roughly 18.7 kilometers. Now we want to find the size of the angle BCA. BCA, that's this angle here. Now for this part, we can use the sine rule. So we want to find the size of the angle BCA. What we can do now is to say, all right, use the sine rule. We have a side over angle equals side over angle. So we can say 18.7. Let me use a different color for that. We can say 18.7 over the sine of 105 is equal to 15 over the sine of the angle, let's call it C. Once you do your manipulation here, we end up with cross multiplying it. 18.7 times the sine of C is equal to 15 times sine 105. Fast forward into there, we get the sine of C will be equal to 15 sine 105 divided by 18.7. And once you do that, you would get the sine of C. It gives you a decimal number to be equal to 0.775. Again, this is very important. Remember to write it to at least 3 decimal places to avoid errors. So 0.775 once you punch that into your calculator, and make sure your calculator is in degree mode. Because we're here now, we can find C by using the inverse sign. So we can say C is equal to the sine inverse of 0.775. Remember, we use the sine inverse when we're finding the angle, and that should give you 50.8 degrees. So that's the second part of the question, 50.8 degrees. That's the size of this angle here. And the third part of the question is asking us to find the bearing of A measured from C. So this is C, and the question is asking us to find the bearing of this point measured from this point. Because we're dealing with a bearing, again, we need to set up another knot line. So we set up another knot line here. I'm trying to, let me use a different color so it can be easily seen. I'll use a green. So we have that knot line set up here. All right. There we go. So we have our knot line, and now we want the bearing of this point measured from here. So the bearing has to be measured from the knot line. So we need to take that bearing all the way around to this line. And that is the direction that would take us back to A, all of this angle. We already know that this part of the angle, we just did the calculation, is 50.8. What we do not know is this side over here. We know this side because right here, this section, being straight, is 180 degrees. That's very important. So this side of it is 180 degrees. And we just did the calculation for here, which is 50.8. So we need to find this piece right here. To find this piece right here, we need to make use of our Z angles. Now, notice this is a north line here, and this is a north line here. And the idea is that north lines are parallel to each other. So when you take out this piece, this north line and this north line, notice what happens. This north line here and the other one here. And we have an angle of 60 degrees here. Then once you do that, remember north lines are parallel to each other. And because they are parallel to each other, we can clearly see a Z. Here's a Z. And because of that, we call Z or alternate angles. We can find this angle here because these two angles will be equal to each other, which means that this angle here is actually 60 degrees. Just from looking at the geometry of the alternate angle. And now we can find our bearing, because our bearing will now be equal to, in part 3, our bearing will now be equal to 180 degrees plus that 60 degrees plus that 50.8 degrees. Once we add up all of that, we can see that the bearing of A measured from C is 290.8 degrees. So this is the solution for this question. We have some more to look at. Let's look at another one. Or you feel free to pause and go it over until it makes sense. Here we have another one that we need to draw. This one says a port M is due south of a lighthouse L. A ship leaves M and sails 200 meters on a bearing of 60 degrees to port K. K is directly east of the lighthouse. All right, so let's draw that. First, I want to push this up a little bit to give us some more space. All right, there we go. So first, let's draw the diagram. So the question says M is due south of a lighthouse L. All right, since we're dealing with bearings, first thing, we need to draw our north line. All right, here is our north line. And M is due south of L. So this would be L, and we have to go south to get to M. So let's extend this and call this point here M. Now I'm putting another north line here, continuing this north line, so M will be here. And we are told that now the ship sails from port M, leaves port M, sails 200 kilometers on a bearing of 60 degrees. So measuring the bearing from the north line, we can put in our 60 degrees, and that 60 degrees would end up being here. That's our bearing. Now we are told something else, that K, this ship is going to sail from M to K. We are told that K is directly east of the lighthouse. So this is the lighthouse, which means that we have to extend this line outward. And then this 60 degree is going to intersect, we're going to meet that one. So K has to be directly east. So we end up with a nice right angle triangle that we can apply our tools, our trigonometry tools to, and find out what we need to find out. So here, this is our right angle triangle. We know that this part is 90 degrees because it's between the north, between the east and the south, and that's 90 degrees right there. All right, when a latitude meets a longitude, we end up with right angles being formed. So we are supposed to show some things in the diagram. Let's make sure we have them. The points L, M, and K. L, M, and K, we have those. The angle 60 degrees, we have that. And the distance 200 kilometers. This is the distance 200 kilometers. So let's write that in. So we have the things that the question required. Now we're asked to do some calculations. At part C, we're asked to find to the nearest kilometer the distance LK. Now we can find that because this is a right angle triangle. We can use sine ratio to find it because LK here is opposite. It's opposite to the angle here, and this is the hypotenuse. So we can simply say that the sine, in answering part C, the sine of 60 degrees is equal to the opposite side, which is LK, divided by the hypotenuse, which is 200. And a simple cross multiplication will give us 200 sine 60. That will give us LK. And once we do that, then we can punch this in our calculator, and we should get approximately 173 kilometers. Bear in mind that we are supposed to calculate the nearest kilometer. So LK would be equal to 173 kilometers. All right. Now, another part of the question, part D, says we are supposed to indicate or show on your diagram the angle X, which shows the bearing of M measured from K. So we want the bearing of M measured from this point, meaning if you were at this point and you wanted to go to M, what bearing would you use to get there? Remember, all bearings are measured from the north line. So we need to set up a north line here so we can measure the bearing. And because we want to measure that bearing now, we need to draw the line from the bearing from the north line to that particular line. So this would be the angle that would take us to the point M in case we wanted to sail there. So this is our X that we need. So indicate on your diagram X, which shows the bearing of M measured from K. Notice the question didn't ask us to calculate it. It simply says just show. And this is the angle that we're talking about that shows the bearing of M measured from K. All right, let's look at another question. Sometimes CXC will send a question that you need to draw. More often than not, though, they will give you a question that is already drawn that you need to manipulate and use your tools to find the answers for. Now, in this question, we have a diagram not drawn to scale of an airplane flying from one place, Port City, which would be here, P, to Queenstown, which would be here, and then to Riversdale, which would be here. The bearing of Q from P is 132, that is shown, and the bearing of, and the angle PQR, that is also shown, is equal to 56 degrees. Now we're supposed to calculate the value of X. The value of x is here. Now recall that this is a straight angle, and straight angles measure 180 degrees. So in answering part 1, we can simply say 180 degrees minus 56 plus 48, and that would give us 180 minus 104 degrees. And doing that calculation tells us that x degrees is equal to 76 degrees. So that's that. That's for part 1. Now we're told that the distance from Port City, P, so the distance from Port City to Queenstown, Q, is 220 kilometers. We can write that in. 220 kilometers. That's this distance. And the distance between Queenstown and Riversdale is 360 kilometers. So that's that distance there. We are now asked to find the distance RP. And RP is opposite to this angle. Notice that we have this angle, this side, and the angle between them. And because of that situation, we can use the cosine rule. So we're going to use the cosine rule for that. So we can say part 2, the cosine rule. We're going to use RP square or PR square is equal to 220 square plus 360 square minus 2 times 220 times 360 times the cosine of the angle, and the angle there is 56 degrees. Once you type that into your calculator, there's no need to work it out manually. Just type in the whole thing and make sure that you type it in correctly. You should get 89,424 kilometers. Now we need to find the square root of this. So once you find the square root of that, your answer for RP or PR should end up being 299 kilometers. So that's PR or RP, whichever way you want to say it. 299 kilometers. Use the cosine rule. Remember, the cosine rule is a square is equal to b square plus c square minus 2bc, in this case, cosine a. Type it into your calculator, find the square root, and that should be your answer there. And now we get to part 3. And part 3 is asking us to deal with determine the bearing of R measured from P. So we want the bearing of R measured from this side up here. So let's draw in that angle. We already have the knot line. So we want to find this. If you were here at P and you wanted to go to R, then the bearing that you would use is this bearing. Remember, bearings are measured in a clockwise direction, so you'd have to use clockwise. So you'd go this way and not that way. So we go through this angle. And because we go through this angle, we now realize that we need to find this part of the angle. So we need to find here in order to get our answer. This angle needs to be found. We can find that angle using the cosine rule, the sine rule rather. So we can say, we could use the cosine rule to find it because we have all 3 sides. But let's use the sine rule to find it. So we can say the 299, that's this side, which is 299. So 299 over the sine of 56 is equal to this side, 360, divided by the sine of the angle opposite to it. That is the sine, let's call it P. And cross multiplying, we have 299 sine P gives us 360 sine 56. Then we know that sine P is equal to 360 sine 56 divided by 299. And once you punch that in your calculator, you should get 3 decimals. Write it to 3 decimals. The sine of P is equal to 0.998. And P, therefore, we use the sine inverse of 0.998, and that gives you 86.4 degrees. Remember, this is not our bearing. It's this part of the angle, 86.4 degrees. And we can now write down our bearing, because our bearing would be this angle, 132, plus this other part, which is 86.4. And when we add those two, our bearing is now 132 plus 86.4 degrees, which gives us a total of 218.4 degrees. So this would be the bearing of R measured from the point P. Let's look at another one. Here we have a diagram, not drawn to scale, of course, of 3 ports, P, Q, and R. Q is 80 kilometers from P, and R is 100 kilometers from Q, and the bearing of on a bearing of 66 degrees. PQR is 54, that angle is shown. So we are asked to show first up the bearing of P from Q. So it said the bearing of Q is on a bearing of 66. R is on a bearing of 66 from this point Q. So the 66 goes here. And that is exactly what the question wants you to do here. So we're done with that. The distance PR is here. It's set up quite nicely for us to use the cosine rule again. So in doing that, we can simply write in the cosine rule. And the cosine rule would say that PR square would be equal to 100 square plus 80 square minus 2 times 100 times 80 and the cosine of 54. Once you type that into your calculator, you should get 6,995 and find the square root of that, which would give you approximately 83.6 kilometers. There are no restrictions on the answer here, so I'm just writing it to 1 decimal place. So we have 83.6 kilometers. All right, so we are finished with this part. Well, it says 2 decimal places actually. So we can look at part 3. So just write back your answer to 2 decimal places there. The measure of angle QPR to the nearest degree. The measure of QPR to the nearest degree. So QPR is here. So we want this angle. All right. QPR. We want that angle to the nearest degree. And let's just fix this part first up here. So we have the square root before we go to that part. The square root of 6,995. And that should give you 83.63. 636, which should give you 64 kilometers. Now that we've fixed that, let's move on to the other part of the question. The measure of this angle, again, we can use the cosine rule to find it because we would have had all 3 sides, 83 point, we're going to keep it as 83.6, but we can easily use the sine rule as well. So let's use the sine rule for keeping them in our memory. So we can say the sine of the angle, the side over the sine. So 83.6 over the sine of 54 will be equal to 100 over the sine of the angle here. Let's call it P. cross multiplying, we have 83.6 times the sine of p is equal to 100 sine 54. And therefore, the sine of p would be equal to 100 sine 54 over 83.6. So once we punch that calculation in, we will end up with 0.968 for sine p. All right. Now remember that this is not the angle, it is the sine of the angle. So we need to say that now angle P is the sine inverse of 0.968, and that should give us approximately 75 degrees written to the nearest degree. So the questions they can be difficult, but they're not inherently difficult. They require many tools. They require a lot of geometry knowledge, and they require that you know the advanced trig tools such as sine rule, cosine rule. In some cases, you will come across sine or cosine or tangent, but in most cases, it is a sine or cosine rule. Let's look at our final question, which the diagram is drawn for us as well. So like I said, sometimes the question will be drawn for you. In a lot of times, the questions have all been drawn. But sometimes you may be asked to draw or fill in missing parts of the diagrams. So be prepared for either to draw it or to use the drawn diagram to get what you want. Now, this one have some distances here. PQ is 120 kilometers. PR, we see that. And we have QR, and we have the angle 23 degrees here. So we're asked to find, first up, straight calculation, the distance QR. To find QR, of course, because we have the two sides and the angle between them, we go straight to the cosine rule. And the cosine rule will tell us that two sides and angle between. So we say the cosine, answering part 1, part A. The cosine rule would be 120 square. Well, let's actually start it properly with the side. So QR square will be equal to 120 square plus 150 square minus 2 times 120 times 150 times the cosine of the angle 23. And once you, that doesn't look like 23, that looks like a lot bigger number. It's 23. All right, once you punch that into your calculator, you should get your answer, but let's do it. So QR, 120 square plus 150 square minus 2 times 120 times 150 times the cosine of the angle 23, and that should give you 3,761.8. Of course, that is in kilometers. And now your answer, QR, would be the square root of this, 3,761.8. So we find our square root, and that should give us 61.3 kilometers. So QR would be equal to 61.3 kilometers. The area of the triangle is something else that we need to calculate. And in calculating the area of the triangle, we need to use a different tool. There's a tool for that. We can use the formula A is equal to area. Let me write that instead of A. The area is equal to half AB sine C. It's a very important tool to know and use. And we can use that tool whenever we have the two sides and an angle between them. So we have AB and the angle between them, similar to the cosine rule, except we're not calculating a distance and we're using a sine instead. So it's half times A, the product of AB, and the sine of the angle between them. So we can simply punch that in, as half times 120 times 150 times the sine of 23, and that should give you 0.5 times 120 times 150 times the sine of 23, and that should give you approximately 3,516.6 3,516.6 kilometers square. Remember that it's the area of the triangle that we're finding. And the final part of the question is talking about the bearing of P from Q. And the bearing of P from Q is 252 degrees. Calculate the bearing of R from P. Okay, so let's put this one in. The bearing of P measured from Q. So here is P measured from Q. It is 252 degrees. Okay, we have that down. And we are asked to use that information to find the bearing of R measured from P. All right. So the bearing of R measured from P, let me just draw that in, is going to be this angle. Remember, you have to measure from the north line. I should write it better. I'm blocking out that 23 degrees. I don't want to do that. Right, so let's draw it a bit smaller. So this is our angle measured from the north line. This is the bearing that we want. So we're given this bearing. The bearing of P measured from Q is 252, and we're asked to use that information to find the bearing of R measured from P. Okay, so what do we know here? What we know here is that this side of the triangle, this side of the angle rather, let me just shade it in for you. This side is a straight angle, and that measures 180 degrees. So we can say 252, take 180 out of that. 8 from, we've borrowed there, 8 from 15 is 7. And so we have this angle to be 72 degrees. So this angle right here is 72 degrees. And because we know that this angle is 72 degrees, our job just got a lot easier. Because remember, north lines are parallel to each other. So this north line will be parallel to this north line. And because they're parallel, we end up with an alternate angle situation where we have, let's put it in red so we can see it easily. So here, oh, this is not red. So here we go. That, let me trace it to there, to here. So there's your Z. And because of the alternate angles, this angle here would be equal to 72 degrees as well. And so now we can find the bearing of R measured from P, because if we're finding the bearing of R measured from P, we want this angle. So it's simply equal to 72 plus 23. And that is going to give us 95 degrees. But remember, bearings are written with 3 digits. So we have to write down now our answer is 095 degrees. And so that would answer that. The questions that pop up on section 2 of the paper, which are some time ago, they used to be optional. They're not optional anymore. They are compulsory. You have to do all 10 questions. And this question comes up under geometry and trigonometry. They're useful questions. If you practice with them, you can really gain a mastery over them, because CXC does not do a lot of variation with these questions. So it is, once you practice a few of them, then you realize that you can handle them. The most important things that you need to know are the basic stuff of knowing sine rule, knowing cosine rule, and understanding how angles and parallel lines work, cointerior angles, alternate angles. Once you know those and you practice with it, you need to know the basics first and practice with it so that you don't get frustrated. And of course, if you're having difficulty, talk to somebody, get help, watch the video more than once. Pause the video, make sure you work out the question, look at it. If you don't get it, talk to somebody, and make sure that at the end of it, because the important thing is that you understand what you're doing and grasp the entire concept, not just a piece of it, and then you go make mistakes and cause confusion, but that you understand the entire thing. Thank you for watching, and I hope that this practice session would have given you some more insight into those kind of questions.